Good afternoon, ladies and gentlemen. Thank you for your interest in this presentation about assisted inspection data evaluation from aerospace to other industries. My name is Guillaume ITHURRALDE. I'm the Chief Technical Officer of Testia Group, an Airbus company. Our core business is focused on the inspection of aerospace components, including services and products. First, I would like to acknowledge all my Testia and Airbus colleagues who contribute to the development, the maintenance of NDTkit UT software, in particular the co-author of this presentation from Testia, Mr. Bakri, Bertrand, Dutey, Kamenev, Safir, Lazare also, but also the specifiers from Airbus, Silver Baru, Franck Bentouami, Romain Eco, Louis Leparu, etc. There are many, so sorry if I forget a few of them. In a nutshell, this presentation deals with ultrasonic testing, data reading and processing, diagnosis assistance, digital continuity, cloud-hosted databases, digital twins, etc. Consequently, it's related to many topics related to NDE 4.0 concept, which is often discussed nowadays. This presentation is split into 4 sections. First one introduces the UT data processing, the context. The second one focused on diagnosis assistance for aerospace. Third one deals with possible transfers to other industries. And last one includes the conclusions, a few references and acronyms. Let's start with the context. Ultrasonic testing data are recorded in various formats, depending on the proprietary software of the companies which provide the acquisition system. Most of the associated analysis software are black boxes, which do not allow users to add specific features. This situation causes difficulties for industrial companies to capitalize on dedicated post-processing tools for their application and to take advantage of the latest artificial intelligence developments. So what is the solution to face this problem? Since 2004, Airbus invested in the development of NDTkit UT software to overcome these barriers. This software also manages the huge quantity of UT data acquired in its plants involved in the manufacturing of airframe component made of CFRP. Here you can see the example of the wing cover of the A350, which corresponds to approximately 50 megapixels. This software guarantees also the possibility to read raw data all along aircraft life cycles, typically 20 to 30 decades, 20 to 30 years on average. So 2 videos hosted on our YouTube channel are available for you if you want to have an overview about this software and to follow a webinar. Let's continue with the second section about diagnosis assistance for aerospace. Diagnosis. This table lists several statements valid in the aerospace market in the A left row. They are translated into requirements in the B middle column. The C right column includes the corresponding features in NDTkit UT software to fulfill these requirements. So let's start with the first line. The first statement says that various UT methods are used to scan 100% surface of airframe components made of CFRP. As a consequence, several readers are needed to load various formats generated by the UT equipment suppliers. Consequently, the compatibility with more than 20 major partners is possible thanks to NDTkit UT, and we can manage A scans, multi-peak, or C-scan, so any kind of data, any kind of UT data. The second statement says that UT aims to detect foreign objects, delamination and disbonding, but also evaluate porosity and porosity content, and evaluate the thicknesses. As a consequence, a requirement is that we need dedicated analysis tools to circumscribe the flows, to cluster them according to proximity rules, and to position them. In NDTkit, you have all this. You have anything that you can expect. So you can regate the A-scan. You can apply a software time-corrected gain. You can filter the signals. You can zoom and unzoom. You can position some layouts, position some selections, some mask, compute some signal-to-noise ratio, etc., etc. Third bullet, composites are inspected most of the time with normal incidence. That means with 0 degrees longitudinal waves because of anisotropy. As a consequence, we don't need any volume-corrected views, like, for example, for weld inspections. And we just need to compute what we call straight B-scans. So that's possible also with our software. 4 bullets, 3D scanning is a must for all the non-developable components. And there are a lot in the aerospace because of aerodynamic concern. So as a consequence, we have to manage 3D data, either point cloud or what we call trajectories-based. And in NDTkit, we have all the 3D visualization, projections on cuboid, faces, etc. There are a few slides which will illustrate this. 5th bullet, human factor has to be controlled and software regression is prohibited because of airworthiness. NDT is used to assess this airworthiness. As a consequence, we need a high degree of automation to reduce the human factor, and we need also a rigorous validation process of the new software release. So in NDTkit, we have an automation sequencer to chain recurring actions so that the operator can focus his attention on the key steps of the analysis. And we have also implemented unitary and function tests a lot. 6th bullet and last bullet, data have to be reviewed for the whole life of the aircraft. So, as I said, around 20 to 30 years minimum. So this requires software maintenance, and that's what we have with Airbus. We have a sustaining contract with them, and we have also a continuous development process. So now let's have a look at most relevant features of NDTkit UT. First, it is compatible, as I said, with more than 20 different formats from major partners. Here you have an overview. It manages A-scan, multipeak, and C-scan. NDTkit UT allows to process data acquired with semi-automatic or automatic systems, scanners. It is able also to load data from single crystal transducer or phase array probes. It allows to load data from conventional air-coupled ultrasonic or laser UT, which are recent alternative to standard UT. And you can analyze data from pulse echo mode or through transmission mode or even tandem techniques. For 2D data, NDTkit UT includes anything that you expect. You can regate the A-scan, you can compute B-scan, C-scan, F-scan, which correspond to frequency scan. You can apply software TCG, filters, etc. For the C-scan, you can apply layout, selection, mask. You can merge C-scan when necessary. You can compute SNR, etc., etc. For 3D data, here you have an example of the section 19 of the A350. You can visualize the 3D. I mean, the time of flight C-scan here of the section 19 of the A350. And then you can project the data on some cuboid on one face of the cuboid, and then you can process the data on 2D, but keeping the link with the 3D, even on huge files. These slides highlight NDTkit UT advanced features, which help operators to focus their attention on suspicious area. Indeed, there is an automation sequencer which enables to chain recurring actions and export results in a report, which can be doc file, PDF, Excel, or anything else. And you can include some print screen and some tables of the results which were computed. This software is validated thanks to a rigorous unitary and function test, and it is maintained by a contract, as I already said. Airbus requested to develop some exporting features to allow to display defects contour directly on the digital twin in the CAD software, so here in 3D Experience. These features save a lot of time during the concession management process between the manufacturing plant and the design office. It also reduces the risk related to human factor when analyzing the papers or PDF reports and redraw the defects contour in the CAD software. This slide is a perfect illustration of digital continuity, isn't it? Here is a slide which focuses on the latest features of the version 4 of NDTkit UT that we released beginning of January this year. It includes several novelties: readers of additional formats, 2D and 3D segmentation of huge files, statistical processing. So here again you have an illustration on the wing cover, which is splitted into several tiles. Several operators can analyze these tiles in parallel, which saves a lot of time, and then everything is compiled in a single report. There is also the possibility to connect NDTkit UT to database. We can compute some over-thickness detection. There are also some smart gates, etc., and much more. So now let me present some benefits, examples of NDTkit UT in other industries than aerospace. It is quite easy to propose proof of concept studies to other industries which want to add specific features to NDTkit UT, thanks to scripting possibilities accessible from the main menu. Both Testia and customers, developers can prototype these new features and test them immediately, since they are instantaneously available also from the main menu. For confidential features which have to be industrialized and maintained, the software architecture makes it possible to develop plugins which are independent from the kernel and belong to the customers. NDTkit UT, NDTkit UT allows also specific development of plugins. That's what I said. Okay. So the first example of transfer is related to a specific plugin aiming to measure bond lines along wind turbine blades. You can see the small red lines which corresponds to the bonded area between the spar and the blade cover. So thanks to a dedicated computer vision algorithm, NDTkit UT is able to measure the glue width on B-scan on the left side. All the results are exported to an Excel sheet as requested by the customer. Values below the acceptance criteria are highlighted with red captions. So on the right side, you have the C-scan, which corresponds to the length of the blade, and you can see immediately the areas where the bond line is too narrow. The second example is also related to wind energy. It illustrates ultrasonic testing data visualization on a pull-throughed spar cap of wind blades. So here again, you have a red line which corresponds to what is the spark gap in a cross-section of a wind blade. So this data that you can see were acquired thanks to our Smart U32 phased array instrument and our Easy Wheel probe at 1 megahertz, because this kind of composite has a structure which is quite macro, so 1 megahertz is a good frequency. The stacking sequence is clearly visible in the B-scan in the middle of the picture. And you can see also the joints between the inner joints, both on the B-scan and also on the amplitude C-scan on the right side of this picture. The third example refers to the 3D representation of pultruded profiles commonly used for the construction. The 3D coordinates of the 3 defects detected on this tube, I hope that you can see them in red, in the bottom side, on the left side of the picture, detected on this tube are reported in the defect table at the bottom of the window. And as you can see, we keep the link, we keep the 3D coordinates of these defects in the reference of the tube. In the transportation sector, many structures include composites. Here, 3 examples: pressure vessel for hydrogen storage, there are plenty in this event, train bogies, and sport car frames and panels. So here you have an example from BMW. So all these applications already benefit or can benefit from NDTkit UT software, and there are also many more. And I hope that you can present a few of them to us during this event. Time for conclusion. To summarize this presentation, let's highlight 3 main ideas. NDTkit UT software was initially developed to cope with Airbus needs in 2004, especially to face challenges related to CFRP components. It became the reference software in the aerospace supply chain. We delivered some licenses to most of the major actors in the manufacturing of composite parts for Airbus. It offers also a lot of benefits for other industries, like, for example, the ability to load many different UT formats, to process them automatically, to generate reports, to export results to digital twins, and all these capabilities during decades. Some companies from energy or other transport trust this software to check raw materials quality, bond line, etc. And Testia is open to analyze any new challenge related to NDT data processing, not only UT, since we are developing also other modules for X-ray, for eddy current, and for infrared thermography. Here is the list of acronyms used in this presentation to finish, and a few references. Thanks for your attention. If you have any question, feel free to ask them now, or to come and visit our booth, or send an email to contact@testia.com. Thanks a lot.